Periodic electrical testing is crucial for maintaining the safety and reliability of essential electrical systems. The frequency of these tests is dictated by several factors. Firstly, national and local electrical codes, most notably the National Electrical Code, provide specific testing mandates. It is important to consult these codes for detailed requirements related to the type of equipment and its operational usage. Secondly, equipment manufacturers often provide recommended testing intervals in their product manuals. These recommendations should be strictly adhered to, as they are based on the specific design and performance characteristics of the equipment. Thirdly, historical maintenance records provide valuable insights into the effectiveness of past testing frequencies. Reviewing these records can help determine whether adjustments to the testing schedule are necessary. Fourthly, risk assessment plays a vital role. The potential consequences of equipment failure and the importance of the electrical system to patient safety and overall operations must be carefully considered. Higher-risk systems and equipment require more frequent testing. Common testing frequencies for various components of essential electrical systems are as follows. For emergency power systems, including generators, distribution equipment, and transfer switches, annual testing is generally recommended. For life safety systems, such as fire alarms, smoke detectors, and emergency lighting, semi-annual or annual testing is typically required. Vital medical equipment, including defibrillators, patient monitors, and other critical devices, should undergo monthly or quarterly testing. Circuit breakers and fuses should be tested annually or more frequently if tripping occurs. Ground fault circuit interrupters, or GFCIs, require monthly or annual testing. For electrical distribution equipment, including transformers, substations, and main switchboards, annual or semi-annual testing is generally sufficient. In addition to testing frequency, there are specific requirements that must be met during electrical testing. Firstly, all testing must be performed by qualified electrical technicians who possess the necessary knowledge, skills, and experience to conduct the test safely and accurately. Secondly, established testing procedures must be followed meticulously. These procedures ensure that the tests are performed consistently and reliably. The results of each test must be carefully recorded for future reference. Thirdly, accurate documentation of all testing activities is essential. This documentation should include test dates, results, and any corrective actions that were taken. Fourthly, it is imperative to ensure that all testing complies with applicable codes and regulations. This includes not only the National Electrical Code and local electrical codes, but also any other relevant standards or guidelines. Several additional tips can help to improve the effectiveness of electrical system testing. Consider using a computerized maintenance management system, or CMMS, to track testing schedules and results. A CMMS can automate the scheduling of tests, store test data, and generate reports. Establish a work order system for scheduling and completing testing tasks. This system ensures that all testing tasks are properly assigned, tracked, and completed in a timely manner. Train maintenance staff on proper testing procedures. Well-trained staff are more likely to perform tests accurately and safely. Conduct regular audits to verify compliance and identify any areas for improvement. Regular audits can help to ensure that the testing program is effective and that all requirements are being met. When performing electrical system testing, several specific tests are commonly conducted to assess the condition and performance of various components. For generators, load bank testing is used to verify the generator's ability to deliver its rated power output. Insulation resistance testing, also known as a Megger test, is used to assess the condition of the generator's windings. Voltage and frequency regulation testing is performed to ensure that the generator maintains stable voltage and frequency under varying load conditions. For transfer switches, contact resistance testing is used to measure the resistance of the switch contacts. Timing tests are performed to verify the switch's operating speed. Insulation resistance testing is also performed on transfer switches to assess the condition of the switch's insulation. For circuit breakers, contact resistance testing is used to measure the resistance of the breaker contacts. Trip time testing is performed to verify the breaker's operating speed. Insulation resistance testing is also performed on circuit breakers to assess the condition of the breaker's insulation. For transformers, turns ratio testing is used to verify the transformer's turns ratio. Insulation resistance testing is performed to assess the condition of the transformer's windings. Oil testing is performed to assess the condition of the transformer's oil. For batteries, specific gravity testing is used to measure the specific gravity of the battery electrolyte. Voltage testing is performed to measure the battery's voltage. Load testing is performed to verify the battery's ability to deliver its rated current output. For ground fault circuit interrupters, trip time testing is performed to verify the GFCI's operating speed. Trip current testing is performed to verify the GFCI's trip current. The National Electrical Code, or NEC, contains numerous articles and sections that pertain to the testing of essential electrical systems. Article 700 covers emergency systems, which are intended to provide power to essential loads during a power outage. Article 701 covers legally required standby systems, which are intended to provide power to loads that are required by law to be operational during a power outage. Article 702 covers optional standby systems, which are intended to provide power to loads that are not essential or legally required, but are desired for convenience or business continuity. Section 700.3 details the testing requirements for emergency systems, including the frequency and type of tests that must be performed. Section 701.5 outlines similar requirements for legally required standby systems. It is crucial to consult these sections of the NEC to ensure compliance with all applicable testing requirements. When performing electrical system testing, it is important to use appropriate test equipment. Multimeters are used to measure voltage, current, and resistance. Insulation resistance testers, also known as megometers or megas, are used to measure the insulation resistance of electrical equipment. Load banks are used to simulate load conditions on generators and other power sources. Circuit breaker testers are used to test the operating characteristics of circuit breakers. Ground fault circuit interrupter testers are used to test the operating characteristics of GFCIs. Power quality analyzers are used to measure various power quality parameters such as voltage, current, frequency, and harmonic distortion. The interpretation of test results is a critical aspect of electrical system testing. Test results should be compared to manufacturer specifications and industry standards to determine whether the equipment is operating within acceptable limits. Deviations from these limits may indicate a problem that requires further investigation and corrective action. For example, a low insulation resistance reading may indicate that the insulation is damaged or contaminated. A high contact persistence reading may indicate that the contacts are corroded or worn. A slow trip time may indicate that the circuit breaker is malfunctioning. It is important to carefully analyze all test results and take appropriate action to address any identified problems. Corrective action should be taken promptly to address any problems identified during electrical system testing. These actions may include repairing or replacing damaged equipment, cleaning or tightening connections, adjusting settings, or performing other maintenance tasks. It is important to document all corrective actions that are taken, including the date, description of the problem, and description of the corrective action. Follow-up testing should be performed to verify that the corrective actions have been effective. In addition to the testing requirements outlined in the National Electrical Code, there may be other applicable codes and standards that must be considered. These may include local electrical codes, state regulations, and industry standards. It is important to consult with local authorities and industry experts to ensure compliance with all applicable requirements. For example, healthcare facilities may be subject to additional testing requirements under the guidelines of organizations such as the Joint Commission. The importance of proper documentation cannot be overstated. Accurate and complete documentation is essential for demonstrating compliance with applicable codes and standards, tracking the performance of electrical equipment, and identifying trends that may indicate potential problems. Documentation should include test dates, results, corrective actions, and any other relevant information. This documentation should be maintained in a secure location and readily accessible to authorized personnel. Regular audits are an important part of an effective electrical system testing program. Audits should be conducted periodically to verify compliance with applicable codes and standards, assess the effectiveness of testing procedures, and identify any areas for improvement. The results of audits should be documented and used to make necessary adjustments to the testing program. Continuous improvement is a key principle of any successful electrical system testing program. The program should be continuously evaluated and improved based on experience, feedback from stakeholders, and changes in technology and industry standards. This may involve updating testing procedures, adopting new technologies, or providing additional training to maintenance staff. By continuously striving to improve the testing program, it is possible to enhance the safety and reliability of essential electrical systems and minimize the risk of equipment failure. Proper electrical system testing is important to maintain an adequate level of safety. Failures in electrical systems can lead to electrocution, fire, and equipment damage. Thorough and scheduled testing programs will identify and mitigate these risks. Following the manufacturer's requirements and specifications are important because some devices may be more susceptible to failure if not properly tested or maintained. For example, a generator kept in a standby mode that is only tested at infrequent intervals may not perform up to standards when needed in an emergency. Thorough documentation is also a very important part of the maintenance and testing program. Details from the electrical system inspection should include the inspector's name, any problems found, and corrections made. This detailed history will help technicians spot trends that may indicate possible future failures. It is also beneficial to have up-to-date documentation of the electrical system for maintenance. These documents should include all blueprints for the electrical systems as well as single-line diagrams. When performing maintenance or testing on equipment, it is important to follow all the recommended safety procedures for working with electricity. This may include wearing personal protective equipment, such as safety glasses, gloves, and hearing protection. Always de-energize all systems prior to performing maintenance, whenever possible. Follow all lockout-tagout procedures to ensure no one will energize the system while working on it. Use calibrated test equipment to verify the system is de-energized before starting work. If you must work on an energized circuit, be sure you are qualified and have the proper equipment for the job. In summary, electrical system testing is a complex process that requires careful planning, execution, and documentation. By following the guidelines outlined in this discussion, it is possible to develop and implement an effective testing program that will ensure the safety and reliability of essential electrical systems. Remember to consult with qualified electrical technicians and industry experts to ensure compliance with all applicable codes and standards.